And so let's finish out this problem. Let's make our predicted cost and figure out what the absolute error and the absolute percentage error is for our problem. So I'm going to have to add in a couple columns here, and so I want to add in at least 3 because I'm going to use those. So I want to still have that space in there. And so what I'm going to do is the predicted cost, and this is going to be my regression equation, and then I'm going to run an absolute error. So I'm going to run my May and my MAPE test. So absolute error, and then absolute percentage error. Now let's make those wider so we can see what's going on. So I do want to make range names here to make things a little bit easier for myself. Left column, and let's just build the regression equation. So our regression equation is going to be the intercept plus the units produced times the variable for that plus whether or not it's plant 2 times the coefficient plus, and once again I can't highlight that, I'll use the right arrow key, times plant 3. And so there's my regression equation, and let's change this into currency. And we don't need the cents, so we're going to round that. And then I will, now typically if I'm doing this on my own, I'll end up doing all 3 columns here and then dragging them down at once. In fact, let's do that. That'll just be a little bit easier. So absolute error. So what is absolute error? Absolute error is the distance. So we're going to do the absolute value of the number. Now, so what we need is the distance between the total cost and the predicted cost. Since we are doing the absolute value, it really doesn't matter which direction that we go, because if there's a negative sign, absolute value gets rid of that, and that's just going to tell us exactly how far apart 2 things are. And so there we go. Once again, we're going to change this to currency because absolute error, since it is a straight out number, is going to be in currency. And so this is not the May, by the way. This is just the absolute error for the first observation. So now we're going to do the absolute percentage error. Now, the absolute percentage error is just going to be the absolute error divided by the initial prediction. So we can just go absolute error and then divide it by the initial total cost. And if we needed to, we could just write out this and put it in there, but it gets us the same thing, so there's no really point to that. And so let's bring this to 2 decimal places. I'm going to highlight all 3 of these, and I'm going to drop it down. Now, I am not done. I'm going to have to actually calculate out May and MAPE now. So as I said, these absolute error, absolute percentage errors are not our May and MAPE. We still have one more operation to do. And so remember, the M in both May and MAPE is the mean. So what we have to do is we're going to take the mean of the absolute error. So we will average together, we will average together this entire column. And so what does this tell us? This tells us on average our predictions from our regression model are off by $2,749. Okay, let's look at MAPE. So mean absolute percentage error. We're going to do the same thing. We're going to average together everything in the percentage. And so 2.5. So on average, our predictions are off by 2.5%. Look at the first one, mean absolute error, 2,800. Well, that could be a lot, that could be a little. If you're only talking about $10,000, that's a lot. If you're talking about $10 million, that's nothing. MAPE, on the other hand, is a awesome measure because it is a percent. And so we can look at things and go, on average, we're off by 2.5%. That's actually not bad at all. So last one, determine the predictions that are within 1,000 of the actual total cost, as well as the percentage of the predictions that are within 1%. percent of the total cost. So we are going to do a count. So we are going to count within. So we've got two different things. So within $1,000 would definitely be along our mean absolute error. The 1% is the mean absolute percentage error. And so what we're going to do is we're going to spool up a variable here, count within. So $1,000. Again, let's put that currency. And even though it's like, oh, well, I'm doing it, I know it's currency, I know what the units are, you always have to think that somebody else is going to be accessing these spreadsheets and looking at them, so you want everything to be clear. And then count within 1%. Okay, so how are we going to do that? We're going to run a count. We're going to run a count function. And remember, we've got a special kind of count function. We are going to run a count if. So equals count if. And so the range. Well, our count if range is going to be the absolute error column. Really should have made that a range name, but that's okay. Now, we have to give the criteria. Now, this is not like since we've got an entire row, it's not like we can say each individual one of these, well, 34, is it less than or equal to? Because it's not going to work in the Excel coding. So what we're going to have to do is we're going to have to put an equation together like we did before. So we're going to give a text string, and that text string is less than or equal to. And then what we're going to use is we're going to use the ampersand, which is the and symbol, shift 7. And we're going to put that together, and we're going to say our count here. So what does that do again? This is putting together a string of code. So what it's going to do is it counts through each one. It's going to check the criteria, and the criteria is going to be, is that individual cell going to be less than or equal to K54? So what we do is we have it in the parentheses, it types it out. The and symbol allows you to take a cell reference and add it to text. And so basically this allows us to build that little filter. So each one it goes down through, it's going to check each individual one to see if it's less than or equal to this cell that we made here. And with that, we'll close the equation and we'll hit enter, and that's the count. So there are exactly 11 values that are within, that are less than or equal to $1,000 of difference. And so let's just do that real quick. It wants to know the percent. And so that percent is going to be equal to this number divided by, we're going to count up the entire list. And there we go. And so that tells us that, it's in dollars. We don't want currency, so we're going to go up. We want a percentage, and there we go. So that tells us that 22.92% of our predictions are within $1,000. So the last thing that we're going to do is we're going to do the percentage, and it's going to be the same thing. We're going to go equal. We're going to do a count if statement. The range is going to be our absolute error, and then we're going to put together a function saying less than or equal to ampersand and our 1%. We will close that up, hit enter, and so we have 12 of them that are within 1% of the cost. And same thing, we're going to take this, we're going to divide that by a count of how many values that we have. Once again, I know range names would have made that easier, but change that over to percentage. We have exactly 25% of our data points that are going to be within $1,000. Within 1% of our prediction. So that's not too bad. It's looking pretty good. And there we go. So that is a regression analysis using dummy variables. If you have any questions, please let me know. Otherwise, I will see you in the next video.